Hello and a warm welcome, grade 10s. I'm your host, Mr. T, and it gives me pleasure to be presenting to you this topic on transformation. And we're talking about transformation of algebraic graphs this time around. I know you'd have done transformation in grade 9, and in grade 9 you dealt with the 4 types of transformation involving translation, rotation, reflection, and enlargement. But what you focused on in grade 9, you were looking at transformation of coordinates. Much as they could have come as triangles or quadrilaterals, it doesn't matter. But the focal point is that you were transforming coordinates. So under transformation of algebraic graphs, we're going to focus on, in this video, just translations. So with translations, there are 2 types of translations, which again you would have covered already. The first one involves vertical shift. And with vertical shifts, you would recall that this only affects your y values. In other words, it's an upward movement or downward movement of your graph or your points. We move on to the second type of a translation, and this one involves a horizontal shift. With horizontal shift, it's the exact opposite, and this one will affect the x values. In other words, it's a leftward movement or a rightward movement of your graphs. But to cap it up, I'm going to move on straight to an example where we're going to look at the following. Translate the following graph through a shift of 2 units up. What graph are we given? We are given f in x is equals to 2x squared minus 3. It has to undergo a movement of 2 units up, the whole graph that is. You also know that what is affected is only your q value, that negative 3. And it gives rise to a new expression f of x plus 2 as the translated graph. And in so doing, you get 2x squared minus 3 plus 2. To give context here, your f of x is that 2x squared minus 3, and that's your f of x. The plus 2 is the movement of 2 units going up. And so if we simplify, we get 2x squared minus 1 as the equation of our new function or the translated graph. We move on to the second example where we're given a different type of a graph, a function, which is, in this case, a hyperbola. G of x is equal to 3 over x minus 1. It has to undergo the same translation of 2 units up. So we're going to say g of x plus 2 will give us 3 over x minus 1 plus 2. And this gives us g of x plus 2. Finally, that gives us 3 over x plus 1 as our new graph or the translated graph. We move on to another example where it's going to be asked differently. But before we do that, just to reiterate, shifts involving upward or downward affects the q value. I've already reiterated that, and I'm just emphasizing yet again because it's important. But we move on to the next one where we're given a different scenario. Again here, it's a translation, but let's have a look at it. We're told that if f of x is equal to negative x squared plus 4 is translated through 3 units to the left and 1 unit up. Write down the coordinates of the new turning point. So what are we looking at, or what are we looking for? We are looking for the turning point. Turning point being the highest point or the lowest point of your graph. But if you look at f of x, just to help you analyze that, your f of x from that graph, you can see that the coefficient of x squared is negative, and therefore it should have a maximum value. So the maximum value there for your original turning point, if you want in coordinate form, you can write that the original turning point would be 0:4. Now, we need to translate that point through 3 units to the left and 1 unit up. This you'd have done in grade 9. So we go straight into it and just say the turning point after translation would be, you're going to say 0 minus 3:4 plus 1. In case somebody has forgotten, the 3 units to the left is indicated by that negative 3. The 1 unit up is indicated by that plus 1. And if we simplify that, we're going to get -3 is to 5 as our new turning point. I hope that's easy. We then move on to the last question, the last example. This time around, we're given an exponential function. G of x is equal to 2 to the power x minus 1, and that is translated through 1 unit down and 2 units to the right. Now, what is the question? The question wants us to write down the asymptote of the new graph, not graphs, the new graph. It's asymptote, that means there's one. That's actually a reminder that an exponential function has got one asymptote. Let's get into it. So to answer that question, I'll start by sketching the graph. Just to remind you, so that graph we have an asymptote at -1, y is equals to -1, and it will be an increasing function. Increasing function, why? Because your a value, that base, is greater than 1. And hence, it's an increasing function. And obviously, it's going to pass through the origin, and we'll have an asymptote at y is equals to -1. That's the starting point. So it's important for you to know the original picture first before you move on to your image, your reflection, your transformed graph. So now we're going to start by saying the asymptote of the translated graph of g of x will be, you start by saying y is equals to -1, which is your original asymptote, but then you are told that that graph would have been shifted or translated 1 unit down and 2 units to the right. So 1 unit down, that 1 unit down, you need to subtract. So you're going to subtract -1. And so you're going to get your final answer as y is equals to -2 as the new asymptote. One might wonder, but why did we not make use of the 2 units to the right? It's simply because the 2 units to the right will not affect your asymptote. If you shift this whole graph, any graph, to the right or to the left, it will not affect the position of your horizontal asymptote. I hope you enjoyed. Until next time, signing out is Mr. T. Bye-bye.